The broadcast is now starting. All attendees are in listen-only mode.
Good afternoon, everybody. I'm Sharon Dooley. I'm the moderator for today's session on maximizing SQL Server 2016 performance using some of its new features and proper hardware configuration. I'm delighted to welcome our speaker, Maurice DeWitz, who is from Hewlett Packard, and I'm sure his presentation is going to be extremely enlightening. We thank Hewlett Packard for their sponsorship. They are the folks who make it possible for us to have a raffle for Amazon gift cards for every session, and we are extremely grateful for their support. We are only one of many, many virtual chapters, and you can see a list of them here. You can find another list on the past website and sign up for any that you are interested in. Women in Technology doesn't do too many presentations, but at the summit we will have a fabulous speaker at the luncheon, which will be, I believe it's on Thursday of the summit. If you haven't ever been to a SQL Saturday, find one that's happening in your area. They are wonderful events. They are free, except you may be asked to pay for lunch. They're one full day of free training. They're always on a Saturday, and they're all over the world. I know in the Philadelphia one we usually have 6 tracks and 5 sessions in each track. And so it's like going to a conference. It's simply just one day. Summit is almost here. Last week of October, you'll get home in time for Halloween. If you haven't registered, you can still save $150 on your registration by using our code VC15FPS6. And that's also on our website. On Wednesday, there will be a Birds of the Feather luncheon. These are interesting things. You sit at a table because you're interested in the topic. And Julie, who many of you may know since she's a frequent moderator, and I will be at the community table for the first hour of the luncheon. If you haven't met us face to face, stop by and see us, and you'll have a good time. Now, if you want to buy some past logo merchandise, there won't be a store at Summit. There has been in the past, but the last couple of years, they haven't had the store. So you have to, if you want to buy a sweatshirt or whatever, you need to go online and purchase your swag. We are a virtual chapter with no physical presence. We exist only over the internet, but there are local chapters. There's probably one in your area. You can find the local chapters by visiting the past homepage and looking at chapters. And if there isn't one in your area, you can start one. You'll get lots of help from past, and these are a great opportunity for networking in your area. I know our Philadelphia user group quite often has headhunters as at the meeting, so it's a good chance to look for your next better job. You can volunteer with PAS. PAS is basically an all-volunteer organization. Yes, there's paid staff in the headquarters and running IT and stuff like that, but everything else is being done by volunteers. Julie, Mike, and I don't get paid for doing this virtual chapter. We're volunteers. Okay. And this is a great opportunity. And if you just want to do something at the summit, you can be an ambassador to help people find the room that they're trying to find, things like that, get to wear a red vest, etc. And if you're not already a member of PAS, you should be. It's such a valuable source of training and education, and the membership is entirely free. If you registered for the summit for the first time, you automatically have been made a member. And now I'm pleased to introduce Maurice DeWitz, our presenter today. Maurice is a senior Bachelor of Science in Electronic Engineering with Litt Packard, and he focuses primarily on the performance characteristics of SQL Server on the Litt Packard Enterprise platform. Mr. DeWitz understands server and storage performance and how their correct configuration plays a key role in maximizing SQL Server performance in the enterprise field. He has over 20 years of industry experience. He's spoken at prior PAS events and holds a Microsoft SQL Server Data Platform certification and an Oracle OCP certification. And now I'm going to turn the meeting over to Maurice and let him do his thing. Go for it, Maurice. You should have your show my screen button. Maurice, you have to unmute yourself. It says you muted yourself and I can't unmute you. There, I did it.
Okay, thank you. Apologize.
My
Apologies
fault.
for that. So there isn't a presentation where nothing goes wrong, right?
That's
We
right.
all know that.
And you should have your show my screen button now.
Okay. Do you not? Does everybody see this screen? I thought I shared it.
You have to show my screen. Click show my screen.
Oh, I see. It doesn't seem to be responding on this end. I clicked on it. Let's try them. Okay, there we go.
There.
Okay, so we're good now?
Yep. So you might want to do your slideshow.
Great. Okay, Sharon, looks like I'm sharing now.
You want to put it in slideshow?
Right, we should be able to see the presentation now. It does appear to be sharing, correct? All
Yes,
right.
it's visible.
Great. So let's get into it. We're going to talk about, we're going to focus this presentation in two areas. I've clicked it. It should be visible.
Yeah, it is.
Okay. All right. So we are going to break this into two sections. One is going to address new features of SQL 2016 and how to leverage them and what is new in terms of performance. So the focus of the presentation tends to be about performance across the spectrum of SQL Server. And then the second part of this presentation is going to talk about some existing features and again delving into best practices and some things around the hardware platform and how we can make things better. So there's benefit here for even users of SQL, of older versions of SQL as well. So that's how I've structured the presentation, and let's get started here. So we'll talk about performance-related features. And at the top of my list, we have what's called persistent memory. So again, this is a mix of SQL and hardware. So we are going to talk about, we will be talking about hardware and SQL features in this process. So what is persistent memory? Persistent memory looks just like a DIMM, like a memory in your PC. And with Windows 2016 and SQL 2016, it is accessible as either a block device or a byte addressable device. There we go. Can you hear me now?
Yes.
Okay. Can you see my screen now?
Yep.
Okay. So I think you missed a lot of that, but what we're focusing here is on new features of SQL 16 and also existing features and how to leverage them in terms of your hardware platform and maximize your performance. And the first item on the list here is persistent memory, which is a new hardware feature that is supported by SQL 2016 and even prior versions depending on how we use this. So I'm going to spend a little bit of time around this, and I have a demo. So I apologize for the delays here in getting started, but I would appreciate you giving me a shot here and sticking around for the rest of this. We'll go as fast as we can. So what the NVDIMM is, a persistent memory device, looks just like your memory DIMM. And it can be used as a byte addressable device, just like your memory is, but also as a block device. And the advantage of persistent memory is that it's much faster than flash. So we're talking about access speeds as close to DRAM speeds. And for example, currently with Windows 2016, storage spaces can use a persistent memory device as a write-back cache in front of a SSD pool. That's one way to leverage that and accelerate even SSDs. There is an enhancement in SQL Server 2016, which is called Tail of the Log. That's already been released. You have that in your RTM. So if you have an HPE server with a persistent memory device, you can enable that that functionality with trace flag 9921. So it's officially supported, and HPE is the only vendor that provides NVDIMMs in the market today. It can also be used, again, as a regular block device all the way back to Windows 2012 R2. There is a device driver that can be installed to support that. And the current density of the NVDIMM product is 8 gigabytes. Now that does sound small, but we'll get to some impressive gains here in just a moment. Like I said, where does this fit in? This persistent memory is operating at nearly DRAM speeds. It's faster than SSD. It's much faster than your hard disk. And we're getting up there to cache, as close to cache speeds as we can. So this is a great way to accelerate your workload, your SQL database workload. This product will work with SQL 2016 in either the traditional regular engine or an in-memory engine as well. So the tail of the log functionality that I mentioned is compatible with both features. I'll leave this here for a moment. Again, we've got some pretty impressive gains from a compare perspective. If you're looking at SSDs and PC i.e. accelerators, we still outperform those devices. So what does tail of the log mean? What does this do? So there is a portion of the transaction log that used to be written to persistent media, and by persistent media meaning your disk, your drive, whatever LUN you use for your log. There are portions of the transaction log that are hardened to disk before you can operate your next transaction, right? Before you commit, you have to harden that transaction log entry to persistent media. What SQL Server 2016 has done is it hardens the transient portions of the transaction log into persistent memory DIMM. So it's safe, and it's doing this at DRAM speeds. Once this tail of the log, which is a 64K segment of the transaction log, it's a buffer, is full, it gets flushed out to persistent memory. And one of the enhancements here internally, what this has achieved is that process used to be a serialized process. So every transaction written to this buffer had to be hardened to persistent media one at a time. It was a serial bottleneck. And now the engine has been modified, and these transaction entries are written asynchronously to this buffer at a much higher rate. And that 64K buffer then gets flushed to persistent memory directly as a byte addressable device. So in the context, I know that was a lot of technical terms, but here's a picture that kind of explains why this speeds up the process. When you look at a byte at a block device, right? So if you look at the left-hand side here, that's normally the path of a regular I/O to disk. You have to go through all manner of components in the driver stack to get to your hard drive. And when you use SCM or when you use SQL Server in a persistent media device, some of those components fall out of the picture. And in the far right, when we address the persistent media device directly, as the SCM bus driver does, a lot of components fall off, and there's less kernel time involved in the transaction, in that I/O. And so therefore the latency drops quite a bit. So we're making things simpler, we're using faster media, so it's a win-win any way you look at that. And I have a quick demo here. This is a demo of persistent analytical workload. This is called HTAP, so it's analytical and transactional processing. So we have two workloads, an OLTP workload, and we're going to demonstrate the gains here when tail of the log is enabled. This is done on a DL380 server, and we have a query running here with transaction, a BI query running for 20 seconds. And this is without tail of the log enabled. This is just writing the log to the NVMe SSD. It's the fastest SSD in the HP product line. So I'll pause there for a moment. And this query ran 63,214 transactions per second. And the average time per transaction was about 0.4 milliseconds. And we see the CPU utilization there at around 50%. And that shaded area below is kernel time. That's the amount of processor that is involved in processing the I/O. So I'm going to skip ahead. And now we're running the exact same workload with tail of the log. So you'll notice here right away that the CPU goes up to 100%. So that may alarm some people, but what that means is the CPU is able to process more queries and do more work. Before, it was stagnated at 50%, not because it ran out of CPU, but because of the overhead in writing the I/O and hardening of the log. Now, we ran 125,000 transactions per second. We doubled the transactional throughput. We got better use of the processor because we had reduced kernel time, reduced overhead, and a faster device. So that's an impressive gain. And if you look at the average time per transaction, it dropped in half. So from 0.4, it went to 0.19. So this is really going to be an enabler of performance. This is on a single socket DL2. A DL380 server is a 2-socket server. In this test, we ran with only 1 socket. It's 24 cores. So that's making better use of the hardware you have. If you look at it this way, you can do more work with less cores, so potentially you can lower your licensing costs if you free up some of the cores by enabling tail of the log. So there's quite a bit of value here in terms of adopting this technology and SQL Server 2016. So that was tail of the log. One of the new enhancements here, again, many of you may already be familiar with Numa, but I'd like to touch on this. With SQL 2016, there is a rollout of automatic soft Numa. So what does that mean is, by default, if you don't change anything, soft Numa is enabled, and it's going to partition your hardware Numa node into a different, more granular number of nodes. And that made sense. Microsoft did some measurements, and they realized that smaller Numa nodes got a little bit better performance. However, HP already does something very similar. So there are some features in the BIOS that's called the Numa Grouping and QPI caching methods that impact how the server presents the hardware Numa node to the OS. And so we have, on one hand, we have hardware Numa, which is what the platform gives you, and an overlay from SQL Server, which only SQL Server sees, right? This isn't visible to the OS. The software Numa partitioning is sort of a virtualization, if you think of it, of the hardware Numa node. We did some testing, and at the end of this presentation, I have some links to to where you can download the reference architectures that we put together, and we did some testing, and in some cases, the hardware Numa node under the new partitioning HPE provides actually outperforms the soft Numa node, and so it's one of those where you want to test this in your own platform. Don't take the default for granted. It's the best option for you. That's the key takeaway here. So especially as you scale up in the 4 sockets and higher cores, it's important to analyze this and test this when you're rolling out a proof of concept or you're rolling out into production a new hardware platform, a refresh. Now, I wanted to touch on this briefly for those of you not familiar with Numa and how to take advantage of this. In Numa, why am I talking about Numa? In general, what we've measured in the lab when we enable and we set up Numa Affinity on a 4-socket or even a 2-socket server, we've been able to achieve gains ranging between 15 and 20% higher transactions per second. And the reason that happens is you tend to have all of the queries from one database, for example, execute in one socket and leverage local memory. And it's a static partitioning. You have to decide, hey, I have 4 databases. I'm going to set affinity to database A and B to socket 1 and the other 2 to socket 2. So it's a little bit of work, but well worth it in the end. What you have to do is set a Numa Affinity mask, and that's based on the socket. So socket 0 will have a bit mask of 1. Socket 2 will have a bit mask of 0010, which is decimal 2, and so forth. And you can mix them up as well. If you want two adjacent Numa nodes to be paired up with a database and not the other two, you can set up a hybrid mask with an overlay. Well, where does this bitmask go? So in your TCP/IP configuration under SQL Configuration Manager, when you specify the port, any application, for example, that targets database A, you can make that connection from your clients, for example, on port 1500, and in the square bracket you'll see decimal 1 or decimal 2. That is the bitmask. So any inbound connections from any application or a specific application that is utilizing that port will have affinity to that. So that's the hard part. I think the hardest part is identifying what your bitmask is, again, under the new hardware Numa enhancements with HPE. For example, a 4-socket platform may be subdivided into 8 Numa nodes. So your bitmask here will be, you will have 4 entries, and you can partition more databases to different subnodes within the socket. Now, also regarding Temp TV, we've all heard, hey, it's great to partition Temp TV into more files. What's nice about SQL 2016 is that we already do this automatically. So it automatically carves this out into 8 files. What's important here is where this gets placed. So it probably defaults to your C drive, and that's not a good location for your Temp DB to reside, right? So you want your Temp DB on SSD media, and perhaps even a persistent memory block device. So that's another use of persistent memory. You can present 8 gigs or a couple of 8 gig NVDIMMs and do a dynamic volume on Windows volume on top of those block devices, and put your Temp DB and stripe it across those. So there's another use for persistent memory, but also again, I know everybody here knows that, but it's so easy to click next, 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 and get those pesky defaults to come and hurt your performance. Now, in terms of scaling up SQL Server, there are some improvements here around max DOP. So check table, check DB, check file group now have a max DOP hint. A portion of that operation is now parallelized. I have not had a chance to test that, but please do follow me on Twitter. I have that in my plans here before the end of the year to test in a scale-up environment. So I'm talking about a 4-socket or an 8-socket server, how much enhancement this brings in, and be able to give you a number. Is it 10%? Is it 50% faster? These are very, very slow operations. Historically, they take a lot of time. So that looks to be like a very welcome change. Also, your max DOP for your database can now be set at the database level. It's historically been an instance level setting. Now you can have some databases in the mix that have a higher max DOP, and you don't have to paint everything with that broad brush. And also with Enterprise Edition, online index rebuilds also support max DOP. Query Store is another new feature of SQL 2016 that indirectly can improve performance. So turning it on doesn't necessarily improve performance, but it allows you to analyze your queries and do regression and to see if your new code has made a certain plan worse. So again, I have not used this extensively, but I highly recommend starting to use this as a tool as you tune your environment. And there are some excellent demos from Microsoft, I'm sure, that cover that tool. Similarly here, advancements on SQL 2016 that cover the database in-memory portion, right? So you have Columnstore indexes that are in memory that can take advantage of an in-memory database, OLTP table, and you get fantastic performance out of these systems. There are some excellent demos. I don't have one for this today, but I will put some of those demos in my links. I will post those on my Twitter account. And it's an area certainly worth exploring if you're looking to squeeze the maximum amount of performance on some of your BI transaction processes.
Maurice,
Okay.
Maurice, why don't we do the questions on the first section now?
Sure. I'll pause for some questions here.
Okay. So the tail of the log persistence is really log buffer cache persistence, yes?
Yes.
And is all this specific to SQL 2016 running on Litt Packard?
Correct.
Okay. Somebody was hoping you would cover how to use these hardware improvements with virtualized SQL servers, but he's gone to a meeting, and that's probably a longer topic than we have time for. Is the tail of the log enhancement only an enterprise edition feature?
To the best of my knowledge, I don't think it's edition restricted. However, to your question, it is currently only supported on physical instances. Microsoft is exploring the option of bringing this into the Hyper-V realm. It is supported as well with VMware. So VMware already supports our persistent memory as a pass-through to the guest. So again, I have not tested the VMware implementation, but from what I've heard, it is available.
And the next question is a related topic. Does Auto Numa work in VMware?
Yes. So the automatic software configuration is a SQL overlay of the Numa platform, and since VMware does present the hardware Numa abstraction to the guest, SQL Server 2016 guest will provide a software Numa subpartitioning if you have that enabled.
And so the client, in the client connection string, you specify port 1500 square bracket 1 close square bracket to target one Numa node?
Correct. Well, not just, it's the Bitmask 1 that matters. So that could be square bracket 2. Does not mean to use 2 Numa nodes, but it means to use the socket number 2, which is represented by 0010.
Will the tail of log enhancement work with an always-on availability group?
Yes, and does. In fact, it accelerates. There are some enhancements in the mirroring portion of the log that have also sped up.
Okay, that's all the questions on the first part. So go ahead with the rest next
Great.
part.
Great, thanks, Sharon. So, and again, this may be recap, or I'm sure most of you are familiar with this. But again, I wanted to touch on these pieces because they're crucial to performance. I can't emphasize enough how many databases I see when I do evaluate some production environments that where we could have gotten more performance out of by following some of these practices. So I covered Numa earlier. I believe I talked about this. This is how we set the port affinity of a Numa node. Anything connected, for example, to port 1501 square bracket 2 addresses this bitmask here, 0010, and that's the second socket. So depending where the digit is, that is representing your socket. This is socket 0, socket 1, socket 2, and socket 3. Now, another big key performance enabler is, as you all know, having ample memory for your buffer pool. And you may not realize the impact. It's not just a memory impact that improves your performance, but as you have more memory in your system, your reads are reduced. And so why is that important? Because by having practically no reads, your I/O subsystem is capable now of processing writes at a higher latency. Your reads are always going to impact and put a load and a stress on your storage array or on your disk controller. So here in this test, what I've done is what's called a memory ramp down test. And I've started a workload on a terabyte, 1.6 terabytes of RAM. This is on a DL580 server with 4 sockets, running 8 100 gigabyte databases concurrently for roughly about 800 gigabytes of data and indexing space on SSD. And I believe the back end here was NVMe Media SSD. So on the left we see a nice stable, a warm-up period and a nice stable plateau here, and I believe the green line here represents the batch requests per second or your transactions per second, around 50,000 transactions per second. And the CPU running at about 80% utilization. Then we memory to 800 gigabytes. Maybe don't see much of a change at all, but still worth it. And right there, just to call this out, right? I like to speak in terms of memory to database size ratio. Here, we are at a 1-to-1 ratio, and everyone will agree. Yeah, well, you have all the memory. You have more memory than you have databases, so obviously that's great. Well, you start taking this down to 600, and performance still isn't hindered almost at all. But if you look at the blue at the bottom, right, all of a sudden your reads start creeping up. And you're talking about, I believe, around 10,000 IOPS. Reads are going to start coming into the picture. Not a problem there. You get to 400 gigabytes, and now you're in a 1-to-2 ratio. So 1 being your memory, your database, and your memory, and 2, your database size. I'm sorry, the other way around. So my memory has dropped to 400. I still have 800 gigabytes of databases. Performance drops a little bit. Reads almost triple. They go up to 30,000 IOPS right there, and we've lost about, I would say, about 10% performance on from 50,000 to 45,000 transactions per second. And things go really bad now. We've dropped to 200, so 1-to-4. And you may think everything is great. Your processor is running at 50%. You're getting, wow, golly, 30,000 transactions per second. But you're missing out on 20,000, right? You've taken a great downfall there, and your reads now are foreshadowing your writes. You're totally crushing your storage array at this point. And I wouldn't even dare go any further, right? So 100 gigabytes and 50 gigabytes, but just to illustrate the pattern here. So in your production environment, are you really caching your reads appropriately, and are you leveraging the maximum performance you can get out of your platform and your storage array? That's the challenge. So in this case, right, this applies to my workload. Your workload may be a little bit different, but I would recommend 1-to-2, no less than that. If you're operating with less memory than a 1-to-2 ratio, you are missing out on performance. And that's the takeaway there. I'm going to talk a little bit about backups here. And again, I apologize, we're going so quickly through this. But the key takeaways from the session have to do with getting to know your hardware platform, working with your SAN engineer or your server administrator, and making sure you're configured properly to maximize your throughput. So this is with respect to a 3-part storage array, and what happens is there are backup optimization parameters that are only available to your command line. If you run a native SQL backup from the GUI, you don't have access to block size or max transfer size or buffer count. But in a T-SQL command, you do. And I recommend testing this, but you can set the block size to the maximum, which is 64K, and 4 megabytes for your max transfer size. Well, why is that important? Well, it so happens that on the 3PAR, there is a read-ahead cache. When it detects a serial reads, for example, as in a restore, or as a read when you're taking your backup and you're reading your data file out to a backup, you're performing a sequential read. The 3PAR device recognizes the sequential read and starts doing read-ahead internally in the array to have the data ready for the next SQL Server request. And it so happens the read-ahead buffer on 3PAR is 4 megabytes. So what I've done here is I've matched it to get a perfect cadence with the device I have behind it. And look at what happened here. So here we have, from left to right, several peaks that represent the bandwidth of the backup. And on the right, I have the service time, or the latency. So as I increase the bandwidth here, right, the parameters, and I started giving it higher transfer size, the bandwidth got higher. It increased a little bit of the latency, but on that last peak, I almost got as high as the highest bandwidth for the backup, but the latency on the array dropped from 125 milliseconds, or I don't know if that's microseconds, but it dropped to the ground. It dropped to practically zero because everything was in cache. And I don't have the actual data for how long the backup shortened, but it is in one of my white papers. Again, I encourage everybody to go look at those reference architectures. But this is the kind of data I like to publish to highlight how important it is to tune. It's like tuning your car. You want to get the highest acceleration. You put in a new chip on your CPU in your car, and it goes faster. Bam. Well, by doing these little bits, little tiny adjustments here, I was able to get great cadence because I matched SQL Server's maximum transfer size to my storage device read-ahead buffer size, and I still got the best throughput, or close to the best throughput, and minimize my latency. Now, here is a quiz to, again, highlight some other why defaults are not a good thing, and what happens to assumptions. We all know what happens with assumptions. So here's a question for you. Of these two downloads, I'm going to install SQL Server 2000, in this case 2014. It's the same for 16. If I were to install it for a 64-bit platform such as the DL580 4-socket server, which one would I pick, A or B? This is MSDN, right? And I'm sure everybody already says, well, of course, B. That's the right answer. Well, no, not quite. It turns out if you go to the, and sometimes this will land on a different page, you might have missed it, but the naming convention from Microsoft says it has to say core. If you download any of A or B, you're getting the CAL-based license, which is a user seat license, and it will only, it's core locked to 20 cores. I've had customers, and I won't say who they are, and I've had it happen in my lab when if you download this image on a 4-socket server and then I get a phone call that it's performing horribly, usually it means you're only running on 20 cores, and if hyperthreading is enabled by default and you're running on a 20-core socket server, you just limited yourself to half a socket. So always make sure you install from a good known source. Make sure you have the core edition, and you can check this by selecting at version and looking at the output to make sure the word core is in there. If not, you're running CAL. Again, you will only be limited to 20 cores, and that's not a good situation to be in. So with that, Sharon, I think I've wrapped up the presentation. I'd love to take some questions on this section.
Okay. I don't know. Right now, they haven't put in any questions, but we will see if they do. They have asked for copies of the slides. So if you could send those to me, I can post them with the recording.
Okay, I have the, and I will put it here. My Twitter account's here. Please follow me for demos. And you can email me here, and I'm happy to email you a copy.
Okay, thank you very much, Maurice, for a very interesting presentation. Okay, now we got lots of questions. If you have downloaded the B version, is it hard to change to the core version?
Great question. Fortunately, it's very easy. So you open the SQL installer, and I don't recall exactly off the top of my head, but there is an option there to update your, and you can enter a license key. And as long as you enter the core-based license key, it will revert to core. And even if you have a trial version, the core-based license is embedded in the CD. When you go to run an installation, it actually presents the license key for you in the setup program. So you basically do two things. You run your setup as if you were going to install up to the point where you see the license key, and you copy it, cancel the installation, then go back to run, go back to the setup menu, and I believe it's under maintenance or license maintenance where you can upgrade your edition, and you can just paste the license key. It automatically fixes it. You do have to restart SQL Server though.
Please give us the link for HP3 PARA03 backup performance testing.
Okay. So for that person, if they would email me that request, I will certainly take care of that.
How does tail of log enhancement compare in speed with delayed durability?
Good question. I would have to get back to you on that, but I believe that what the difference is we are not impacting recoverability or recover time.
Okay, that
So
I was going to ask a follow-on question to that, because the impact of delayed durability, the risk of delayed durability is data loss. But it sounds like tail of log enhancement does not risk data loss.
Exactly what I was trying to say, correct.
Data always seems to grow. What happens when you have no more sockets in your server for memory? If you have tried in-memory tables, can you quickly revert back to normal tables?
That's another good question. I don't know what the reversal process is. I can tell you one of the new platforms that HPE has is called a Superdome X, which goes up to 16 sockets, and it supports 24 terabytes of RAM. So if you really needed to scale up, that's an option for you. And guess what? Windows 2016 officially supports up to 24 terabytes of RAM, as we have worked with Microsoft to make that happen. So that's an option for you. The DL580 is a 4-socket, but I believe it's up to at least 6 terabytes, if not more. So I'm sorry I can't answer the how to regress it, but I can give you some options to increase it.
The question about reverting back to normal tables, at least in SQL Server 2014, is a pain in the tail, because you have to export everything and then import them back into disk-based tables. I know there are a lot of enhancements in 2016, but I haven't looked at them yet. I'm ignoring 2016.
Well, fair enough. The key enhancement is that the in-memory tables support the OS limits, so it's unlimited.
Yeah, it's much bigger, and you can also do things like alter table and stuff like that you can't do in 2014. How do we enable the persisted tail of the log?
So to enable it, you have to specify -T 9921, and that's the startup parameter.
How big does the NVDIMM have to be for tail of log enhancement? Would 8 gigabytes typically be big enough?
Good point, and I apologize for not mentioning that. It's 8 gigabytes is ample. It's more than enough. The segment stored in the persistent memory device by SQL for the tail of the log is 20 megabytes per database. So you have quite a few room for quite a few databases in 8 gigabyte in one single DIMM.
Which add-at command do you use to see the version of SQL Server and whether it's core-based or cal-based?
So it's add version, and also I'll put down here the trace flag for tail of the log. Okay.
Will features like transparent data encryption or data compression also improve performance? Have they improved in performance, I think is the question, in 2016?
I'm sorry, Sharon, can you repeat the beginning? I missed it.
Will features like transparent data encryption and data compression improve in performance in SQL Server 2016?
I don't know if they've improved performance on compression. Again, if you email me, I will look into it and I can give you see if I can give you an official response on that.
Yeah, I will also send you the questions log, which will have the email addresses of the askers.
Oh, great.
Can you do tail of log for just say 5 out of 10 databases on your server, or does it have to apply to every database?
I believe it's an instance-wide setting, so it would apply to all of the databases.
You showed core-based versions based on 2014 Enterprise. Does the same apply to the standard? For instance, should my 2014 SQL Server Standard Edition say core-based?
It's I believe it does. I believe you want to have core, but what you're running into here is that Standard Edition up to and the prior versions of SQL was core limited to 20 cores. So you really you wouldn't get a benefit from getting the core edition. Now keep in mind that with SQL 2016, the standard edition licensing increases to 24 cores. So you can, for example, if you have a 2-socket 12-core server, you could still run into standard edition and get away with it. I don't know if between the 24 and the 4 and using core edition would free up 4 cores over standard edition. You know, let's say so. I don't think it has value, but it's a good question.
Is there a limitation like on always on group? For example, 100 databases per group on tail of the log for optimum performance. Will it work in an environment with approximately 500 consolidated databases on an instance?
Right, that will work because again, roughly each database takes about 20 megabytes of space in the persistent media device. So, and you're not limited to one, right? If you install 4 NVDIMMs and format them for byte addressable raw access, SQL Server will take it, will leverage that. But 8 gigabytes will more than enough cover 500 databases.
Okay, I think that's all the questions. Thank you very much, Maurice. Do send me the slides, including the updates you've added on that last page, and I'll get
Absolutely.
them posted with the recording. Thanks so much.
Great. Thank you, Sharon. I really appreciate you hosting.
Hope to meet you at Summit.
I will be there. That's please be sure to stop by our HPE booth if you have any questions. I'll be there in person.
I will. I'll be there with bells on. So
great.
see you then.
See you. Bye.
Thanks. Bye-bye.